This question is asking us about principal energy levels and the sublevels that they can contain. The rule of thumb is you can have as many sublevels as is equal to the value of the principal energy level. So the first principal energy level can only have one sublevel. The second principal energy level can have two, the third can have three, the fourth can have four, and so on. The sublevels are always filled and always exist in the same order. And I'm going to give the letter designations rather than the angular numbers. The next question will deal with angular numbers. So we always start with S, and S is always followed by P, and P is always followed by D, and D is always followed by F, and then you usually don't get much beyond F, but if you, theoretically, there's G and H, and you could keep going, but we never do, because it's just not practical to see elements that we know of with electron configurations beyond that. To remember this order of letters, St. Patrick's Day fun is good, ha ha, maybe something like that. So if we're listing the sublevels, and I'll say sublevels that exist, because they're gonna, in this problem, they're gonna offer some possibilities that do not exist. So in the first principal energy level, the 1s sublevel would be the only one possible. In the second principal energy level, you can have either the 2s or the 2p. In the third principal energy level, 3s, 3p, 3d. Sorry, and that's it. You cannot have a 3f. Then the fourth principal energy level, you can have 4s, 4p, 4d, or 4f, the same number of sublevels as is equal to the value of the principal energy level. In the fifth principal energy level, you can have 5s, 5p, 5d, 5f, and then theoretically, even though ground state configurations don't go up this high, 5g. 6s, 6p, 6d, 6f, 6g, 6h, gosh, 7s, 7p, 7d, 7f, 7g, 7h, there's one more, but we never see that. You never get beyond even h. I mean, h is ridiculous. 8s, 8p, 8d, 8f. You can keep going. You can get 2 beyond 8h, 9s, and blah, blah, blah. The point here, students, theoretically, there's no limit. As long as you keep this a number of sublevels as is equal to the value of the principal quantum number, then there's theoretically no limit to how many sublevels you can have or the number of principal energy levels that you can have. It's just that the elements that we know of don't go beyond 8s in their ground state configurations. Now, can you take an electron in one of those elements and excite it all the way up to, say, the 10th principal energy level? It's possible. It's just that the amount of energy required to do that is something we've never seen before. So, anyway, this question is just asking us which of the orbital designations are incorrect. In other words, when they're naming sublevels, what's valid and what's not. So let's go through real quickly and make a note. In the first principal energy level, you can have a 1s because that's the first one listed. You may not have a 1p because that would be the second sublevel that exists, and in the first principal energy level, you could only have one sublevel. 7D, that can exist. 9S, theoretically that could exist. That's fine. We don't, no element that we know of has a 9S ground state configuration, but it's theoretically possible. 3F, no. I had to erase that because I was not thinking. In the third principal energy level, you can have the S, P, or D sublevel, and that's it. You may not have a 3F sublevel. That does not exist. But the 4F sublevel exists. The 2D sublevel, no, you can only have S and P because there's only 2 sublevels.